Hey everybody, let's go ahead and get started here on our lesson. Today what we're going to do is we're going to focus on circles. Now the title screen here says circumference and area, but today we're going to focus mostly on circumference. On this slide right here, what we're going to talk about is like where does pi come from, but in order to talk about pi, we need to know what the parts of a circle are called, at least the basic parts of a circle. You should know that, the longest segment on a circle, it has to go through the midpoint, is called the diameter. It's called the diameter. It has to go through the middle. And don't get too hung up on the diameter having to look like that. Diameters, as long as they're line segments, and as long as they go through the middle, it's still a diameter. So everything that I'm drawing right now is a diameter. So some people think like diameters have to be horizontal. They don't. They just have to go through the middle, and they have to have the endpoints, the endpoints of the segments have to be on the edge of the circle itself. Next is called the radius. Now the radius is essentially half the diameter. The radius only goes halfway. It starts at the circle, or I guess you could say it starts at the midpoint, but it goes halfway. And it's, another way to explain what the radius is like the spoke of a bike tire. That's a radius. But again, radiuses can, as long as they begin at the middle and go to the outside edge of the circle, then it's a radius. And then there's another thing here that's not in my slide, but I'm going to show you guys this. What is it called when you have a segment that is not a radius? It could be the diameter, but what this is called here, and you might know this word from especially if you're a musician, but that's called a chord. A chord has the segments that are on the circle itself, but it does not have to go through the middle. Now, one interesting fact here about chords is that a diameter is a chord. It just happens to be the longest chord. It's the chord that goes through the middle. But chords can be all sizes. Well, not too many sizes, but as long as the endpoints are on the circle itself and it's made up of a segment, it could be super, super close to being a diameter. It can go almost through the middle, but that's a chord. But the endpoints itself, the endpoints have to be on the circle. That's what makes a chord what it is. Now next, let's talk about where pi comes from. Now you might know that pi, the most common estimate for pi is 3.14. 3 and 1400ths. But I mean, it goes on in 3.14, 159, 265, 358. Some of you might have this memorized, many digits, but what I would say is most common is 3.14. And where does that 3.14 come from? Did someone just wake up in the morning and say, hey, you know what? Let's make pi represent 3.14. Let's talk about this. Where it comes from is, there's a number of, civilizations that kind of had derived pi in some form or fashion. I think the Greeks get the most credit for it, and it kind of comes from Archimedes, and I think I'll have that name written down for you in just a second. But this is how it goes. What Archimedes did, let me kind of show you here. What Archimedes did was he was kind of obsessed with looking for a connection. What is it about the circumference of a circle? What is it about the outside perimeter of a circle that makes it similar to the diameter? And what Archimedes discovered was that no matter how big the circle was, it could have been a really tiny circle, it could have been a big, big circle, the size, could be a few miles wide, it doesn't matter. But what Archimedes discovered was that if he took the diameter, and let's say he cut pieces of rope, because rope can wrap around round things, if he's using a stick, sticks don't bend so easily, or, a piece of wood or whatever he's using. If you took a rope, he noticed that ropes that, as long as they were the same length as the diameter, he noticed that the rope or the diameters can wrap around a circle 1, 2 times, 3 times, and then there's this like little part right here that's left over. That's the decimal part that is irrational. Now, pi, you might have heard me describe pi as being one of the more famous, if not the most famous, irrational number. So you get 3.14159265. But this, this decimal doesn't terminate, it doesn't repeat, it doesn't end. It just keeps going and going and going and going. Hence the name irrational. It will never kind of work itself out to be turned into a fraction ever. But that's what Archimedes kind of discovered. He discovered that a diameter, whether whether it was a really tiny circle or if it was a really big circle, but you notice the diameters can wrap around the circle 3 times plus a little bit more, So that 14159 part. And that was the part that kind of drove mathematicians, and not just Archimedes, but that's the part that kind of drove mathematicians nutty, because they were just like, there's got to be a way for this to kind of settle itself, or for some way to kind of work itself out. And that part never did work itself out. So like I said, Archimedes gets a lot of the credit for this, but Babylonians, if you guys ever studied that, perhaps in social studies, Babylonians had a form of pi. Indians, and I'm not talking about like Native Americans, but India, from Indians, the ancient Chinese culture, they've been around for thousands of years. They had a type of pi, but it wasn't 3.14. I think Archimedes gets the credit for getting at least to a couple decimal places. So that's the interesting part about it, which, do with that knowledge what you want. But what that basically says is that, let's say you have a circle and you just want to estimate, let's say you just want to estimate. Well, if you know the diameter of the circle, let's say the diameter is of this particular circle that I just drew, let's say the diameter of that circle is 8 centimeters. Well, we could say, based on what Archimedes found out, we can probably safely say that circle, if we talk about how much around it is, we can probably say that it is going to be 8, 8, 8, I know I'm not doing this to scale, plus a little bit more. It's going to be 24 centimeters plus a little bit more, but 24 centimeters around. But I'm not saying it's exactly 24 centimeters, but a good estimate could be, it's about 24. It's probably more. It's probably 25 something, but estimation-wise, that's all you need to know. And another thing too I wanted to talk about was, where does pi come from? Now, pi was, again, someone just didn't wake up, I think, in the morning and just say, I want to make pi the symbol. Now, pi is the Greek letter for P, and P stands for perimeter. Now, we don't call it perimeter of a circle. We call it circumference because it's round. Perimeter is kind of is relegated for polygons. A circle is not a polygon. So that's where it comes from. And I think like an English mathematician, you can look it up, I think, somewhere. But some English mathematician, I think in the 1700s, 1600s, decided, hey, let's use the Greek letter for P for 3.14. And that's kind of where that came from. But the P stands for perimeter, which of course, like I said, perimeter of a circle, we don't really call it that. We call it the circumference. And here's a nice little animation that I grabbed here. You can kind of do with this what you want, but this kind of shows, and I'll let it repeat a few times here, but right here, those circles, I know it kind of goes through really quickly, but those circles, if you look at it, they're each a unit apart. And if you look at that circle, it makes one complete rotation just a little bit past the 3, which means that, each unit represents the diameter of the circle. So that's 1, 2, 3.14159 right there. See how that works? So 1 diameter, 2, 3, and then it rolls, and see the blue part hits right there. See, that's how that goes. Now let's get into circumference. Now circumference is the distance around a circle one time. That's what it means. Just like, but circumference represents the distance around a circle. And the formula for it is this. It's circumference equals pi times diameter. For a lot of our examples here, we're going to use 3.14 for pi. So you got circumference equals pi times diameter. Oh, alternatively, there's another formula for circumference. You might have heard this one before, but it might be 2 pi r, which represents 2 times pi times the radius. And if I kind of clean that up a little bit, I guess I can do 2 times the radius times pi. And the reason that we can get away with that is because 2 radii, radius plural, 2 radii equal 1 diameter. So you can kind of get away with that. That's another approach. But whether you use 2 pi r or pi times diameter, you're going to find circumference. That's the distance around a circle. And we're going to use, for a lot of our examples, I think even on IXL, you're going to use 3.14 for pi, which is a good estimate. I actually should have that symbol there instead of equals, because it's not equal. It's approximately 3.14. So for practice problems here, what we're going to do for number 1 is we're going to find the circumference of the circle. And it says do not round your answers, since we're using 3.14. Now, make sure, I have to kind of give a little bit of a warning here. Some of you, especially if you're using your calculator, you might have you probably do. There's a pi button on your calculator. Now, that is not the same. That is not going to be the same as using 3.14. I have to always preface this lesson and talk about this. Some people think, oh, I'm just going to use my pi button. It's the same thing. It's easier. I don't have to push, 4 buttons to put in pi. I could just hit that pi button, but it's not the same. It's going to give you a different answer. So especially if you're using IXL, where you have to get the right digits, and get the exact right numbers, you're going to want to make sure you're putting in the right figures in your calculator, of course. So I wouldn't use your pi button, okay, unless you're told to. Here, for a lot of our examples, we're going to use 3.14 for pi. So what we're going to do for circumference, remember, circumference is equal to pi times diameter. So pi is 3.14, and the diameter of the circle is 8. So from there to there, that represents 8. And that's all you have to do. So when we're all done with this, we're going to get 25.12. Now, is it going to be meters or is it going to be square meters? Well, it's just going to be meters. If you put a square here, if you put a square there, that represents area, and we're not doing area. We're just doing a distance. We don't tell somebody, hey, I'm going to run 5 square miles today. You just say, I'm going to run 5 miles. If you're running around a track, you didn't say I ran 4 square laps. That doesn't make any sense. You're just going to say meters. So that's it. So 25.12 meters around. That's it. Okay, on this one, again, we're finding the circumference of the circle. We're going to use 3.14 for pi. And it doesn't hurt to write out the formula for circumference. Circumference equals pi times diameter. And when we do this, we're going to do 3.14 times 9, right? Times 9? What do you think? Does that seem right? No, it's not going to be times 9, not at all. What we're going to do is, you got to keep in mind that, think about what numbers you're given here. What is this number that we're given here? That is not the diameter. That is the radius. That's the radius. So there's a couple different approaches you could take with this. Well, you don't have to draw it, but if you wanted to see it, well, then we know that the diameter is 18 centimeters right there. It's just 9 plus 9, or 9 times 2. You could think of it that way. So that's 18 centimeters right there. So you're going to do 3.14 times 18. Okay, now you're allowed, of course, to use your calculators on this one. So if you do 3.14 times 18, you should get 56.52 centimeters. And again, it's not squared. It's just 56.52. So that's a distance around. And like I said, it's just, remember, like we said, where does pi come from? Well, it comes from the diameter wrapping around a circle. So the diameter goes around it one time, goes around it two times, and pardon my sloppiness here, goes around three times, and then there's a little bit more. That's that 1.14 part, 0.14 part. So, it goes 18 here. This is 18, that's 36. Another 18, that's 54. And then 54, and then the 0.14 times 18 is going to give you that, that 2.52 extra there. But you got 56.52 centimeters around. All right, so that does it for your lesson right there. We just focused today on circumference. We didn't talk about area. Area will be the next lesson, which will be Thursday, okay? So everyone have a great day and take care.